Today we're going to talk about normal distributions and how to make calculations of shaded areas under the curve, what those probabilities and their values are. This particular graphic shows the standard normal curve. What you're seeing on this axis are z-score values. For every x value, which is raw data, there's a corresponding z value. The reason why you create z-values is because x values can take on any format. They can be 2 decimals, 3 decimals, 16 decimals, whatever. And to create probabilities, we need to standardize those values into one set of measurements that we can then create reference tables or lookups or calculations from tables. So that's what the z-score allows us to do, is to then create probabilities from those z-scores. So for every x, there's a corresponding z. The z value is the number of standard deviations you are away from the mean. The z value can be minus or plus. So that's the direction of, if I'm one standard deviation away from the mean to the left, say I'm at 100 and I want to go down 10 as my standard deviation, this number would be 90 on my x-axis and minus 1 on my z-axis. The z equation is the distance from the mean, which is x value minus the mean, divided by the standard deviation. So you have this meaning the number of standard deviations that distance is away from the mean. This next page shows what the corresponding x values would look like. You see 100 was the mean. If your standard deviation was 10, each standard deviation is going to go to the left by 10 or to the right by 10. So you'll have 90, 80, 70, 110, 120, 130. These correspond to z-scores, pluses and minuses of 1, 2, or 3 standard deviations away from the mean of 100. One thing we need to be able to do is to look up the z-score within the back of the book in the tables that are provided in the statistics book. So you'll see that in a z lookup table, reference table, the rows are in tenths. So 1.2, 0.0, 3.0, 1.25. These are typical kinds of z-scores. The tenths are the rows, like 1.2. If you wanted 1.27, the 7 is the hundredths column, and that is the 0.07 that you'll see at the top of the column. So the 1.2, if you're looking for 1.27, 1.2 would be a row, and the 7 would be the column that you look at. The probability is inside the cell that corresponds to that row and that column. So if the mean is 100 and standard deviation is 10, here's two different kinds of left problems that you might see. One shaded somewhere to the left of the mean, somewhere shaded to the right of the mean, but it's always shaded to the left. So you can see here that the method to solve for this left kind of condition, left shaded area, is we have two steps. Calculate the z, then look it up in a table, we're done. An example for the right hand shading, this I call a right hand problem, is that we have three steps. We have calculate z for the x value that you're interested in this case 90, in this case 110. You look up the z value in the table. So these two steps are exactly like doing a left hand problem. The additional step is that if we were to look up everything to the left, that's not what we really want shaded. We want shaded everything to the right. Since everything would be 100% or 1, the lookup value is subtracted from 1, and that gives us the right hand side. So 100% minus everything shaded to the left of a number of interest then gives us everything to the right. So we subtract that lookup value, which is everything shaded to the left, from the value of 1. The most complicated part is to calculate the area under the curve between two numbers. In the first case we have 80 to 90, second case we have 90 to 110, and then the third case we have 110 to 120. Even though these shaded areas are on different parts of the curve, it's still shaded area between two numbers and is calculated the exact same way. So the method is the same. The way you solve for this is that you have 5 steps. You calculate a z-value for each x. So for 80 or 90, 90 or 110, 110 or 120, we calculate the z-value for that x. Then we look up that z-value. That's steps 3 and 4. So for each one of the x's, we now have a z and a lookup value. The last step is to subtract the smaller lookup value, which would be in this case, say 80 to the left, from the larger lookup value, say 90 to the left, whatever those z values were, and we'll end up with what's in between. So if we take everything from 90, subtract everything from 80 to the left, we get what's in between 80 and 90. So again, we take everything from 90 to the left, subtract everything from 80 to the left, and we get this shaded region between 80 and 90. In the middle here we have 110 and 90 as our areas of interest. Those are x values. So whatever those corresponding z values are, they're looked up, and then whatever the probability was from 110 all the way to the left, you subtract whatever it is from 90 to the left, and you get what's in between 90 and 110. For 110 to 120, the z-value that corresponded to 120, we looked that up. We get whatever the shaded area is to the left of 120. We look up 110's shaded region for the z-value, and we get everything to the left of it. We subtract the 110 value to the left from the larger value of 120 to the left, and we get what's left over in the middle. The distance here, that area under the curve between 110 and 120. So here's an exact calculation. If we wanted to have the shaded region to the left of 110, first we calculate the z-value, which ends up positive 1.00. The lookup value for that is 0.8413 in the table, or 84.13%. So this shaded region represents 84.13% out of 100%, which would be the whole curve shaded. Here's a right problem from 90 all the way over to the right. First we calculate the z-value for 90. It's minus 1.00. We calculate the z lookup value just by looking it up in a table. That's 15.87%, or 0.1587. We subtract the 0.1587, which would be this area right here on the curve, from everything, which is 1, and we get what's shaded to the right, which is 0.8413, or 84.13%. Now the last example is we have a between issue here. We've got 90 to 110. The mean's 100, standard deviation is 10. The first two steps are that we calculate the z-values, which we've done, minus 1 and plus 1. The lookup values for those z-values as probabilities are 0.1587. That would be the shaded area from the 90 to the left. 0.8413 is from 110 to the left. So we take the small value, 0.1587, subtract it from the 0.8413. We get 0.6826, or 68.26%. So that represents this shaded area from 90 to 110.